Today we're taking a look at applications of our primary trig ratios. So when you hear the word applications in mathematics, we're simply talking about word problems. So today's goal is to learn terminology related to application questions and to be able to effectively use trigonometry to solve problems. So when you look at the angles in real-life situations, there's two possible situations. So this situation on the left, where we've got this archer who is firing his arrow into the air, it creates an angle here with the ground. And when an angle is created like that, we call it the angle of elevation. So kind of like the angle going up. And it's also referred to as the angle of inclination as well. So inclination, like the word incline, means going up. If we've got a situation where the line is going down, so now we're finding an angle related to that line straight across. So this angle here is the angle of depression. Okay, so depression going down. In both cases, the diagonal line makes an angle with the horizontal line. So in this case, this diagonal line is making an angle with that horizontal line right where it starts. Now, the nice thing in this situation, and we've been working with similar triangles recently and been talking about the parallel line rules, but in this situation we've got a horizontal line across the top here, we've got a horizontal line across the bottom here. They are parallel to each other. So we've got a Z pattern here, which means that in the actual triangle that we're working in here, this angle is the same as that angle in the bottom corner of that triangle. So the issue with the angle of depression is that it's outside the triangle that we're actually working with here. But the good news is that that angle at the top outside the triangle is always going to be the same as this angle in the bottom corner of the triangle. Okay? So that's the difference between angle of elevation and angle of depression. And this is kind of obvious, but should be stated. So when a word problem is given, you want to draw a diagram, and in these cases, we're going to use trigonometry to solve for the answer. And again, I don't care how pretty your diagrams are. You just want to get everything labeled properly. That's the biggest issue. So a 3-meter long ladder is leaning up against a building. The top of the ladder reaches 2 meters up the wall. What angle does the ladder make with the ground? So we've got a building, we've got the ground, and we've got a ladder leaning up against the building. Now I'm just going to put rungs on the ladder, like steps on the ladder there, to show that that's where the ladder is leaning against the wall. And now I'm going to plug in information that I know. So I know the ladder is 3.0 meters long. The top of the ladder reaches 2 meters up the wall. So that means the distance going up the side of the wall is 2.0 meters. And they want me to find what angle does the ladder make with the ground. So they want me to find that angle there. So I'm going to put theta in that corner. Obviously this is a right angle here. And now, if you ignore the word problem part of this, it's just a triangle that we're used to solving. So if I'm working with this angle here, I'm going to label this side opposite and this side hypotenuse. So that means in our SOH CAH TOA, we're going to be using O and H, so it's going to be sine. So sine theta equals opposite over hypotenuse. Then we can sub our numbers in. So the opposite side is 2. The hypotenuse is 3. So to figure out what theta is, I'm going to need to do sine inverse of 2/3. Now I'll use my calculator here for this first one, just to remember how to punch this in. Go over here. There we go. Okay, so on my calculator, I'm going to do sine inverse, and then 2 divided by 3, and close the bracket. So that looks exactly like what I have on the page. And when I hit enter there, I get 41.8, but I want to round it to the nearest whole number when we're talking about an angle. And in any of these questions, if it doesn't say what to round it to, I would always round the angles to the nearest degree and the side lengths to 1 decimal place. Okay? Now, whoops, I almost forgot. Because this is a word problem, I need to answer the problem that was asked. So at the end of the question, it says, what angle does the ladder make with the ground? So I would say, therefore, the ladder makes a 42-degree angle with the ground. Okay, so notice everything that my solution includes there. I have a diagram. I have my formula. I've substituted properly into the formula. I've solved the equation. And I've written my final statement. So there's a 5-mark question, and those are the 5 things that you want to include in your solution to get full marks. All right, let's try the next one here. So for this one, a kite is located 60 meters above the ground, and the string makes an angle of elevation of 42 degrees. How long is the string? Okay. So there is the kite string. Draw a kite here. And we're trying to, I'll finish drawing it here. Now these questions are not totally accurate because obviously we've got someone standing here holding the kite. But if they don't mention that here, we're not going to worry about that. So in this case, the kite is located 60 meters above the ground. So that's the height of the kite. So we'll put 60 meters there. The angle of elevation is 42. So that's the angle in the bottom corner here is 42. And we're trying to find out how long is the kite string. And the kite string is that line there. Okay, so now we need to identify our sides here. The 60 meters is opposite the angle. The x is the hypotenuse. So we're back to sine again. So sine theta equals opposite over hypotenuse. Sine 42 equals 60 is the opposite, and x is the hypotenuse. Now hopefully you remember what we do when we run into this situation. So remember when we get here, we're going to swap these two guys so that we get that x up onto the top of the equation. So to calculate the value of x, we're going to do 60 divided by sine 42. And we get 89.7 meters. And that makes sense if we look at our diagram. That's the longest side in the triangle, so that makes sense that it's 89.7. So to answer the question at the end, how long is the string? Therefore, the string is 89.7 meters long. All right, on to the next one. Okay, so a flagpole is held upright by a 30-meter long wire that runs from the top of the pole to the ground. So we've got a flagpole here, and there's a wire that's 30 meters long. That's 30 meters. And that runs from the top of the pole to the ground, so that's our 30 meters. The wire makes a 25-degree angle to the ground. So there's 25 degrees. There's our right angle. We want to figure out how high is the flagpole. So we're trying to find that right there. Okay, and I hope you're a big fan of sine, because this is going to be sine again. It's opposite and hypotenuse. So sine theta equals opposite over hypotenuse. Plug things in. And in this case, we're going to move the 30 over to the left side, and it's going to multiply. And when we multiply those together, we get 12.7 meters as our answer. So the answer to the question, how high is the flagpole? Therefore, the flagpole is 12.7 meters high. So hopefully you have a good sense of the steps involved in these questions. We'll practice these tomorrow. I'm going to leave example 4. We're going to work on that together as a warm-up tomorrow. So we'll see you then. Thanks.